Thank you to today's presenters, as you see at the table here, for volunteering to do this. We have Dustin Yetzer, who has been with Abbott Furnace for 19 years and certainly has worked with many of you in the past. Don Schnars has been with Abbott over 24 years and has handled many, many emergency calls, and some of those calls have been from people on the call right now. Brian Smith has been with Abbott for 7 years and has done many testings of products. Certainly, again, some of you folks on the call right now know him, and I understand that some of you will see him next Monday. Finally, we have Matt Pavlock, who is our field service manager and has been with Abbott for 17 years. As we did look at the people who are on the call, many of you know these four before us, so hopefully those experiences are well, and I appreciate you returning for information here. Adding to that, I have about 18 years in the industry. So at the table today, we have just over 85 years of industrial furnace experience, hoping to leverage that and get back to you with responses on some of your problems that you've submitted to us today. So the format we did take some questions. We'll go one by one through these questions and let these guys answer and see how we go. So we will hold this to about a 45-minute webinar or so. So please submit your questions as we move along, but we'll get right into the questions here. So question number one, without being able to check dew points, why would half of the furnace belt be green in color? That first question goes to Matt.
Good morning, everyone. We get this a lot. When we get a green belt like that, we really suspect water in the furnace somewhere throughout, which would turn your belt green. What we do right here is perform a copper steel test. As you can see it right here. I won't read it word for word, but you go to 100% nitrogen, 1900 degrees, and you're going to put a piece of copper, carbon, and stainless steel on it right through your belt. As you see at the bottom of that right there, depending on what's oxidized, what's bright, it will try to tell us what's going on inside that furnace as well. They do happen to work very well once that test comes out. I mean, if you've got an air leak, that'd be different. If you've got a water leak, then we'll go through and start checking dew points and different things we can do to figure out where that source of water is coming from.
Good. Okay, thank you. Next question is for Don. How often do thermocouples need calibrated?
Okay, we get that question a lot. It's biggest thing is the thermocouples really can't be recalibrated. Some of the expensive thermocouples like the R's and the S's can be sent back in to be recertified and get a recertification with them. But if you have type K's in your furnace, that's the picture here. There really is that they're just pretty much a throwaway thermocouple once you use them. The picture shown here is what happens with type K thermocouple after about 3 months of use in a furnace that's running at 2050. This is what they call the degradation of the thermocouple, or drift, if you will. If you run a furnace over 1700 degrees in temperature, degree F, we recommend changing your type Ks out every 3 months because it starts to drift the temperature that the thermocouple to the instrument sees. On a 2050 furnace, that temperature usually is about 30-degree drift in 3 months. If you're below 1700 degrees, you can get about a year out of a type K thermocouple without that 30-degree drift. So if the question was concerned about calibration, you see we have a calibration lab here at Abbott that we do come to some of the guys that's on the phone here. And we do calibrations of the instruments. And what we check is the millivolt signal that the thermocouple is putting to the instrument. That is what we check, not so much the calibration of the thermocouple itself. So.
Okay, thank you, Don.
Yep.
Okay, question number 3 goes to Brian. I've heard that adjustments may need to be made as seasons change. Is this true? And what parameters are influenced by seasonal weather changes?
Yes, that is true. I can see we have some guys in the local area and north here asking questions. Yeah, generally up here in the, where we do have pretty dramatic seasonal changes between warm and cold. We do see issues in the furnaces and in the buildings. And what that's attributed to is anyone that hears us talk about our furnace atmospheres, the atmosphere in the furnace is required. We have to have a positive pressure in that atmosphere. So we want that atmosphere pushing out the front door and the rear doors of the furnaces. What happens is the weather gets colder and everybody closes the doors, windows, garage doors in the buildings. The air is still trying to force its way into that building. And a lot of times the easiest path it has is down your furnace stacks from the roof. So we end up getting some air ingress through the rear stacks, sometimes through the front stacks. That'll get air in the furnace and you'll start seeing quality issues, discolored parts. And yeah, there are things we have to do. Sometimes we need to increase the flow in the rear of the furnace a little bit in the curtain boxes to give us a little more positive pressure. Sometimes we need to come in and rebalance and turn the rotary injectors a little bit. And then as the weather warms up in the spring, it may require another change. Now, when we start opening windows, garage doors, and letting all that air in the building, then we might have issues with it actually gumming through the furnace doors itself, and adjustments to the rear curtains, replacement of the rear curtains if they're worn. And again, sometimes a change in the atmosphere flows and volumes are required to fight that issue. Yep.
Very good. It's appropriate question when it was 9 degrees out this morning.
Yes.
Okay, question number 4 goes to Dustin. How often should we run a temperature profile?
So the easy answer is generally annually. Many of the people on today have to follow some automotive standard, whether it's CQI 9, potentially an aerospace pyrometry specification called AMS 2750. And those require an annual temperature uniformity survey or temperature profile to measure the actual heat curve through the furnace that the parts see. Some of those codes also require a redo of that temperature profile after a large rebuild if the furnace was taken away from original design parameters. Often if you're increasing the amount of power in one zone that could affect what the parts see, that they ask that be done. Now, it's never a bad idea to do them more often, because what that begins to build is a historical record of changing the equipment. So kind of back to what Don mentioned about the thermocouple degradation, you can see that in the temperature profile. And, if you have a company coming in to do your quarterly calibrations and they're not changing thermocouples, and you can see that change in the temperature profile over time if you do that quarterly or biannually. So it can certainly help to identify a problem before it starts. The other thing is the cooling side of that can often be important, as people in powder metallurgy industry are doing center hard parts, and that degree of gas quench for center hard certainly has an effect on some of the secondary operations, like tempering, machining, those kinds of things. So it can be important to keep an eye on, as even indicators of potential cooling tower challenges. So as often as you can is probably the right answer.
Okay, thank you, Dustin. To question number 5 is for Matt. Why am I having discolored parts? What are things to look at prior to calling Abbott?
This kind of goes back to what Brian touched on. We get our discolored parts for a bunch of reasons. Looking at this color chart, which is very helpful when you have discoloration of your parts coming out. If you see like the yellow color 400 degrees, that's more or less that's coming out of the back of the furnace. By going by the temperature of the the color of the part, the temperature, you can actually look at your temperature profile and figure out where that's happening at. The lighter the colors are, back of the furnace, what we see a lot is Brian touched on, people's curtains are damaged or lowered too little. They're getting air up through the back. Maybe sprung a leak in one of your lines. I mean, it just depends on what color you have on your parts and where you're at, I guess is how I can put that. And as Brian touched on earlier about the seasonal, we do see that a lot up here in Pennsylvania. That's a lot of it. But I mean, the main cause that'll do that is your curtains coming up back. You are getting air up through the back of that furnace, and you got to try to get a balanced flow to help the air get back, or help the atmosphere get back there to keep the air from coming up through the back.
Okay, thanks, Matt. Question number 6 goes to Dawn. How do you replace a heating element or glow bar, and how long do they typically last?
Okay, that's a loaded question as far as how they typically last, how long. That's like asking somebody how long your tires are gonna last on your car. I can make your tires last a half hour on your car, or I can make them last 2 years. So with that is heating elements. A couple things, there's a different distinctions between the heating element and glow bar. Heating elements are usually what you see in the preheat. They're wire wound, usually on a support tube. Those are supplied in typically your preheats, and then your high heats are what they call glow bars, or they're silicon carbide heating elements inside there, or heating tubes. That's called glow bar. Typically your glow bars are higher temperature. You won't see heating elements typically over 1800 degrees usually, because they start to sag too much above that temperature. So when you replace heating elements in a preheat, you can do one at a time. If you have one bad heating element, you can replace that heating element if it broke, or the support tube broke and it cracked your heating element, and you don't have power going through it. You can replace the one without any degradation to anything else in that zone. But glow bars, if you break one glow bar in there and you replace the one glow bar and it's connected, usually they're connected 2 in series, then you start seeing an imbalance in your amperage and voltage. Because if you stick a new glow bar in with an old glow bars typically have their resistance increase as they wear. So now you put a new glow bar in with an old glow bar, the resistance or difference to the new glow bar is actually going to work harder than the old glow bar, and you'll start wearing that new glow bar out faster. One of the biggest phone calls I take is I keep changing the same glow bar in my furnace, and that's the reason why is current takes a path of least resistance, so it's going to heat up that one glow bar the most in that bank. Again, typically, how long do they typically last? The biggest issues is with the glow bars is a lot of people take their high heats up and down in temperature. That temperature variation really wreaks havoc on glow bars. What makes a glow bar wear out faster is the higher percent output that you run on them. If you run them at full blast all the time, your glow bars usually don't last very long. That's why typically your first zone of your high heat is the one that eats the glow bars the most. You tend to change the glow bars out in the first zone of the high heat, because that first zone is the one that works the hardest to get that energy into the part to heat it up to get it to center. Okay.
Okay, thank you. To question number 7 for Brian. What maintenance should be done to our Vericool?
For those of you that aren't familiar with that picture on the screen, that's our Vericool system, or convective cooling unit. What we do is down there at the bottom, you'll see a motor connected to a fan housing, where we'll engage that motor, it'll engage the fan, and we'll actually pull the hot atmosphere out of the furnace on that line on the top. And that'll run through a filter in a heat exchanger. And then the atmosphere goes back into the furnace through those steel braided lines. So we're cooling that atmosphere, putting it back into the furnace to help transfer the heat from the hot parts with the cold gas to help increase the cooling rate. So some of the maintenance that needs done on this unit, as you're pulling that hot gas out of that top line, any buildup that's on your parts, soot, carbon, anything that may be in your furnace deposited or on your parts physically, that's going to act as a vacuum cleaner. So it's going to pull that out of the furnace. It's going to run it through that filter housing, and it's going to get caught in that heat exchanger. So periodically, anywhere from a couple of weeks or weekly to monthly, we'll have to pull that filter, clean that, and then judging on the cleaning of the filter, that time period, we can determine on what the time period is where we have to pull that heat exchanger and clean it. Right behind the heat exchanger housing, there's a magnehelic gauge where we measure differential pressure above and below that heat exchanger. As that pressure difference increases, the magnehelic increases, that's also a good determining factor to tell us we're getting close, it's starting to get plugged, we better go in and clean that heat exchanger and that filter. Another maintenance point or a thing to keep an eye on is the housing, the shaft between the motor and the fan. We put a seal there where we run a very small amount of nitrogen on that seal. As that seal wears, it's set with a regulator to increase that nitrogen flow. And over a period of time, when that nitrogen flow gets excessive, you're going to have to go in and replace the seals between the motor and the fan housing. But that's just kind of a brief description of a Vericool for anyone that's not familiar with them. A lot of the people on the call today have those in their buildings and would have a better understanding of what we're talking about as far as the maintenance on those.
All right, thank you, Brian. Next question is for Dustin. Before we go to that question, thank you. We are getting many questions submitted, both on the question and answer and through the chat feature. Thank you. We are going to monitor all those. We'll get to some of those near the end of the meeting, and the ones we don't get to, again, we will get back to you, but thank you for submitting the questions. Question number 8 for Dustin. Which are the principal failure modes or issues in the brazing process, and how do we solve it?
This is a question that could have its own webinar. So we actually have a brazing troubleshoot guide. You can see it on the screen here. Anybody that would like these, we have them for center furnace, for PM customers, and steam treating as well as brazing. Great guide to get you started on some of the most common troubleshooting things. So we see, frosted parts or oxidized parts. Most of that comes from downdrafts in the stack, some of the things the guys were talking about, seasonal change, those kinds of things. Frosting usually happens in the front of the furnace, and oxidation is usually in the rear of the furnace. Soot on parts. If you have contamination, it kind of depends on whether you're using a paste to make the brace joint or a preform. Some of those have binders in them, so it can be a amount of paste that's being applied. It can also be related to the belt speed on how those binders and what temperature those binders are coming out at. One of the most common things we see is flashing on parts. So anybody on the call that's brazing and potentially even center brazing, you see where you have your pocket with your braze pellet, your preform or a liquid type paste, and you get flashing where it actually wets across the surface rather than staying in the braze joint. So sometimes that's the amount of filler metal, especially if you're applying paste. Sometimes in a manual application of paste, it gets a little excessive. Sometimes it's a simple reduction of hydrogen flow, and increase with a backup of nitrogen or argon, depending on your part. So if we have too much hydrogen, we clean that surface too well, that paste will tend to want to flow across the part rather than down into the joint. Sometimes it's just an inadequate braze. So, where you're checking mechanical strengths or pressure testing. So a lot of times that can relate back to temperature profile maintenance. Is that filler paste melting through the joint? Are you getting good flow of material? Sometimes that's related to belt speed and throughput in the furnace, depending on the load. Sometimes we need a little more hydrogen flow in that situation to help that joint get cleaned up so that the paste can wet through and actually finish the braze. The other point about brazing that comes up a lot is joint fit. So when we're pressing a round socket into a round tube, the hole in the tube is oblong. As you flatten that round tube out, so you're pressing a round hole into an oblong pocket, and joint preparation and the gap around that joint is exceptionally critical, especially for a lot of high pressure fluid applications. So those are all very common brazing failure modes. If there's a specific example that someone had, feel free to reach out and we'll do our best to help you out.
Okay, thank you, Dustin. All right, Matt is up next. I've seen your technicians in our facility with a cart. What does it do?
We do have an atmospheric cart here at Abbott Furnace that we use. This you see it here in the picture here now. It does measure the hydrogen, the oxygen, and the dew point inside your furnace itself. This all kind of correlates when you have discolored parts, something going on with your furnace. You got a green belt perhaps, you got discolored parts that we talked about earlier. We got to figure out where that, if it's air or water, or where it's coming in at, or what we got to do to balance that furnace to get good parts. We have what Brian mentioned about the Varicool there. One thing I want to add on that is you do the maintenance on the Varicool. When you fire back up and you do get discolored parts, I get a lot of calls of they're just one loose bolt, one loose, fitting. That causes a bunch of problems inside your furnace itself. I do get a lot of calls about that. So if you do maintenance on your Varicool, I suggest go over, sniff all the flanges, sniff all the bolts, sniff the braided lines. And if you're still having problems and you got discolored parts anywhere throughout the furnace, we will have our technicians come over with that cart to make sure you got the right dew point, the right oxygen levels, and make sure the hydrogen's going where it's supposed to, front and back, so we have an equal balance of that furnace to get a desired product off your belt.
Okay, we can also mention, these aren't just parts that we take in, these are for sale as well for inside of your facilities. Okay, on to question number 10 for Dawn. Temperature, this is, by the way, one of the most common questions that we received, had something to do with temperature deviation, asked in many different ways. So hopefully we can get you a good answer and fulfill some of those several questions. But the question is temperature deviation. How do you determine if you have side-by-side or zone-to-zone temperature deviation, and how do you fix that?
Okay, so that's kind of like a two-part question. The one is a side-by-side, and that is looking at the temperature inside the furnace where the temperature profile would come into play. And this, what we pulled up here is, this is a typical 3 thermocouple profile that we would run on a furnace. We put thermocouples on the left side of the belt, the center of the belt, and the right side of the belt. And we run these thermocouples the whole length of the furnace through, taking the temperature readings. And then that gives us a nice profile or temperature uniformity survey of what the furnace is seeing as far as temperature inside. This here will determine if you do have a side-to-side temperature deviation on your belt that your product would see. The other temperature deviation that's in that they're asking about is the temperature deviation in the zone. And what that is the difference between the process value temperature and your set point value temperature. So if I have a zone that's set at 2075, typically the deviation alarms are set about 20 degree F from set point. And that's plus or minus. So if I go below 2075 by 20 degrees, typically the horn fires. The horn will sound, giving you an alarm that says a deviation in a certain zone. Usually what happens with that is you start, the glow bars are starting to wear a little bit and you may not be able to hold temperature in that zone. Or the product is heavier and somebody increased the belt speed or put a lot more weight on the belt and for the zone won't hold temperature. That can get into a lot of troubleshooting as far as electrical to make sure that that zone is putting out the power that it needs to heat that part up to that temperature. So temperature deviation, two different aspects there that you can look at.
All right, thank you, Don. To question number 11 for Dustin. We often see discolored parts when we steam treat. What causes that?
So everybody that does steam treating knows you're looking for that, that deep dark blue color on your parts. So oftentimes we see some different colors, and a lot of those are, again, I'll go back to mentioning them on the troubleshooting guide. If you're interested, reach out. We'll get you a copy of it. But so some of the common ones we see are pink oxidation, and that's usually when the parts see too low of a temperature of steam, or the parts are too low of a temperature when they hit steam. So again, it goes back to the setup of the furnace, temperature profiles, making sure everything lines up. We see brown oxidation, and brown and red sometimes are a little close together because they're that red rust kind of brown color. But the more brown color is typically where the parts are seeing oxygen while they're at elevated temperature. A more red oxidation or spots of red is typically where they're contacting water while they're in steam. So if there's actual droplets of water that are coming through the boiler, oftentimes that comes if a blowdown on the boiler where you're emptying out excess residual water in the boiler doesn't happen, you tend to see the droplets condense in the piping and then they come out. There isn't enough time for that to flash off into steam. So that can be a cause of red oxidation. The biggest and probably most popular is black spots or dark areas. And a lot of that relates back to contamination. So if you are doing some machining or some sort of dip on the part, before it goes into the steam treater, the old adage, garbage in, garbage out. So sometimes, there's an ability to remove some of that that the furnace can do, but for the most part, we want relatively clean parts going in so that we don't have those black spots on their way out. Seen white spots, a lot of that is improper filtration. It's some sort of remnant of calcium, something coming out of the water, chemical in the water. Then we talk a little bit about part quality. And so there's typically two reasons people steam treat. One is to add a rust preventative coating. Rather than red rust, we're creating an Fe3O4 blue rust that's quite stable. The other reason that people do that is a little bit of hardness for a wear surface, or they're steam treating to seal the porosity in a fluid powered component, whether it's a pump or a shock absorber, where you don't want the fluid to be able to penetrate the porosity in the part. So if there's issues with sealing in a porosity, sometimes that's a temperature related issue, sometimes that's a time related issue. So if you ever come across a specific requirement or specific problem, reach out. Be glad to help you with that individual case.
Okay, thank you, Dustin. On to question number 12. This one is for Don. How do you know when to change taps on a transformer?
Okay, as Dustin said, we could spend a whole webinar in just in this here too. Okay, changing taps on a transformer. The first thing that you need to determine is what the zone is doing as far as the load goes. So the first thing you want to look at is your voltage and your current that zone is pulling. If you definitely want to have an electrician look at this. You can use the amp meters that are on some of the older furnaces have amp meters, digital or analog amp meters. Some of the newer furnaces or the furnaces that have been retrofitted to a newer SCR package, you have a readout of what the SCR reads, and you can get the load voltage and amperages off of that. You want to look at that zone when it's calling for 100% output and record what the voltage is and the current on the coming out of the SCR going out to the transformer. You have to determine what size transformer you have in that zone to look at what your max amperage is allowed out to that. Then if you determine that your glow bar's resistance, as the glow bars wear, the resistance goes up. So if that resistance has increased enough that you're not pulling enough power to heat that zone up, then you're going to have to move up a tap, which the taps is a voltage tap. So when you go, as a picture here on this transformer, you see the numbers on those different tabs. That's a voltage tap. And the higher the number that you go, the higher the voltage is on that particular tap. So usually you start off on tap 1 or tap 2, and then as the glow bars wear, you move up to each tap as they go. If the glow bars are getting imbalanced, where somebody, like we mentioned before, would put one glow bar in a zone, then you start getting what they call an imbalance. And you'll start seeing an imbalance in your current and also in your voltage between banks, between legs. If you have that, going up a tap is not going to help you. You're going to start damaging equipment, mainly SCR fuses. You'll start blowing fuses on your SCRs if you don't have a proper balance on your zone. That's one of the telltale signs of glow bars being mismatched or imbalanced. Then if you determine that your load is balanced and you're just not pulling enough amperage, then you can go up a tap, and then you just take each one of them legs, those lugs right there, and you move it down to the next tap. You want to make sure that you do all 3 banks the same, because this is a 3-phase system. They're not separate phases. So you have to determine, if you look at your SCRs, the SCRs also have what they call a current limit on it. And that's going to limit the current that's going out to this transformer to protect it from overheating. If you would happen to take that too high of a tap and reach that max current, and the max current is going to be determined by your transformer size. So the example is, if you have a 60 kVA transformer, you want to take 60,000 divided by the voltage that you're supplying to that transformer, which is typically 480 in North America. And then you divide that by the square root of 3, which is 1.732. And that'll tell you what your amp. So if you had a 60 kVA transformer, the max amps that you're allowed out to that transformer is going to be 72 amps. Okay. So if you move up a tap and you would happen to hit that 72 amps, the SCR is going to start cutting the voltage back and trying to protect from overheating that transformer. A lot of customers don't realize that when they put all new glow bars in their zone and they were on tap 4, and you're putting too high of a voltage on there and your SCR is cutting it way back, you actually lose power by doing that. So that's definitely we can talk about this for another hour, but it's definitely going to be done by an electrician or by a qualified maintenance person that's going to be doing that. So again, when we get into this, I take several phone calls on taps and how to determine it and glow bar balancing. So if anybody has this problem, they can reach out to us.
Okay, thank you, Don. For the next question is for Brian. The next question is something, if you've been in the heat treat industry very long, you've heard some terrible stories about. Certainly, hopefully they're not with your facilities. But the question is, we are replacing a muffle. How fast can we ramp it up? And then what problems can be experienced if the heating rate is too fast?
So we have a procedure wrote up that would feel free to share if anybody's interested. So we put our new muffle in, our furnace is cold. We're going to bring that furnace up to 400 degrees. We always ramp at 100 degrees an hour Fahrenheit. And that, as Donnie talked about, the glow bars, the electrical components, everything, that's going to give us a nice even heat rate. We're not working things too hard to bring it up that speed. So we're going to bring it up 100 degrees an hour. We're going to get to 400. We're going to stop for 2 hours. And then we're going to do our next step. We're going to ramp up again 100 an hour, and we're going to stop at 800 degrees for 2 hours. And we're going to come up to 1200 degrees. We're going to stop there for 2 hours. The important step in the process is the next one. We're going to come up to 1800, and we're going to stop there for 3-4 hours. And the reason being that stainless steel, 1800 degrees is kind of the sweet spot where as that muffle heats up, it's going to stretch, it's going to grow a little bit. And that's where we're going to see the most growth in that 1800 degree range, because those grains are growing. And once we get to 1800, we let that sit for a few hours, those grains are going to grow to their kind of maximum size. So after that, the grain size is kind of set in season. And then we'll go ahead and we'll bring the furnace up to operating temperatures, whether it be, 2000 degrees to 2050, 2080, whatever your operating temperature is. And then we'll be able to, add the atmosphere in and go through production. So kind of an interesting thing we threw in here is a picture of a muffle that probably nobody would believe if we told you that the age of that muffle. But you can see they brought that up way too fast. You can see how it lifted and bowed because we didn't give it time to, stop and season and grow. So basically they ramped that muffle from 0 degrees to 2000 degrees in a matter of hours. They bowed it up, and it bowed so bad, if you could kind of see on the second picture, the holes burn in the top of the muffle and on the side there. Those are from the glow bars of the heating elements, where the muffle grew up and it actually hit the heating elements and it burnt those holes in it. But that was a picture taken. A guy here told me that muffle is 2 days old. They dropped it in the furnace and ramped it from 0 to whatever their operating temperature was in a matter of a few hours. And, the next day they were ripping it back out again. So, to get the maximum life out of these components that are very expensive, there is a seasoning period and a ramp up period that we recommend for. And that also would work for furnace belts as well. They're a similar grade of stainless steel. And that would, also increase your belt life as well as your muffle life to follow those procedures.
Okay, thank you, Brian. Okay, question number 14 goes to Dustin. We're having a lot of soot buildup. Is there anything I can do to clean it out?
question comes around quite often, especially with our powder metallurgy customers that tend to have some lubricant that has dissociated and turned to soot in the furnace. The belt tends to drag it out the back sometimes, but often it builds up along the edge of the belt. So sometimes when you're changing belts, you can scrape or brush some of that out of there. Sometimes it's quite hard. So the other option is doing what we call burnout. And we do have a written procedure for this. If anybody wants it, glad to share it. But basically it's removing all the atmosphere out of the furnace, so it's just air inside. And this is done in a very controlled manner, and introducing your outside air, oxygen into the furnace at an elevated temperature that will essentially burn that material up. Now, if this is the first time you're thinking about doing this and there's a lot of buildup, there's smoke going to come out of everywhere. So just be cautious, take it slow. But that's one thing that can help. One of the things that often comes up after the fact is due to all of the system components, the belt, if it's still in there, the muffle, those things oxidize. They're doing the same thing that we talked about earlier, trying to prevent the parts from oxidizing. All the internals oxidize. So often to get the furnace back to good production condition, that takes days of atmosphere flow, of normal atmosphere flow, to get all of that internal oxidation removed. You know, the hydrogen reduces the oxidation out. So to get that cleaned up can be a couple of days, and that's something that's often forgotten. You know, that people try to sneak a quick burnout over the weekend, and sometimes it ends up taking a few days and sets the production team.
Okay, thank you, Dustin. We do have a quick poll question that we'd like to put up and get your response back, basically with the helpfulness of this webinar for you. So it'll be a poll rating on 1 through 5. If you could select the best, we'll take a look at that and try to better take the information going forward. We did get a very good response to this, both prior to the webinar and during the webinar. We've got a lot of questions. So hopefully we did answer your questions appropriately. We do owe you some questions that came in over the last hour, and we will get back to you with those responses as well. So we'll give you a couple seconds here to rate this webinar. Okay, they'll get those results together for us. But again, thank you very much for participating in this webinar series. If you do have further questions, our email address is up on the board now. And you know, a lot of you know the 4 gentlemen sitting around the table. Obviously, feel free to reach out directly to them. I do see we have had quite a few new LinkedIn followers over the last hour. Again, if you haven't had a chance to do it yet, scan the QR code and follow us. We will give the hat and sweatshirt away in front of Don there. We'll announce that at the end of the week. So we very much appreciate your time and your questions, and we look forward to speaking with you again. And thank you very much.